and volumetric conversion. Let's start with double conversions first. And you may think to yourself, they look kind of scary-ish, but in reality, if you take them a bit at a time, they are not that bad. So let's try this. First of all, when I say double units, what I really mean are something per something else, like miles per hour. Isn't that a double unit? You have 2 units involved in one particular expression, right? So how do we handle double conversions? Well, we handle double conversions 1 conversion at a time. Let me show you what I mean. Let's say I gave you 25.2 kilometers per second, and I want you to convert to meters per minute. So write the problem down. We're going to work that as our example. Kilometers per second, I want to convert to meters per minute. And if I can emphasize to you that these problems are literally the exact same problems we've been doing, except instead of doing things in 1 step, we're going to do them in 2 steps. So remember our tables, how we always put the thing in the upper left-hand corner? Don't we have kilometers per second here? So what we do is we go 25.2 kilometers on the top, and see this bottom right here? We put the seconds down below. Isn't this the division line? So for the first time, we're actually going to have units down below. Now, here's where I want to make this, like, you can make these problems brutal, or you can make them really, really straightforward. Let's try the really straightforward way. Ready? If I were to give you this problem right here, and we ignored the bottom completely, could you convert between kilometers and meters?
Yes, sir. Yes.
So let's do that, okay? Ignoring the bottom, wouldn't I have to use the expression 1 kilometer is equal to 10 to the 3rd meters? And couldn't, again, we can only do either the top or the bottom independent of the other one. So couldn't I go 1 kilometer on the bottom, 10 to the 3rd meters on the top, kilometers cancel, and wouldn't I now have the unit that I'm looking for on the top? Meters. We don't deal with the bottom unit at all until we're taking care of the top unit completely. But don't we have seconds on the bottom? But what do we want to have on the bottom? We want to have minutes, right? So completely independent of the previous problem. Now, by the way, sometimes they'll keep the bottom unit the same, which is just like not even have to worry about it. But here we have to go from seconds to minutes. So don't we know that 1 minute is equal to 60 seconds? Now, the only difference in these problems is this. Aren't we starting off with the unit down below here? And since the unit's down below, in order to cancel it, mustn't we put the unit above it? So aren't we going to just use this expression? But how am I going to cancel out this unit using this expression, this conversion? Would we go 60 seconds on top and 1 minute on the bottom? Agree? Now watch. What's canceled? Seconds cancel. And look at the unit I have now on the bottom. Isn't that the same unit I want? So when you're done, the unit, and you can circle them if you want to. You don't have to, but the unit you have on the top and the unit on the bottom need to be the 2 units you were trying to get to. So then you go ahead and you write, all right, my units at the very end of this are meters per minute, which is not a very attractive unit, but it is what it is. Are there any exponents in this problem?
Yes.
Thank you. Isn't there times 10 to the 3rd on the top? Nothing on the bottom. And then don't we have 25.2 and 60? Everything else is a 1, isn't it?
Yeah.
What's 25.2 times 60? Can someone punch that in real quick?
1, 5. I got it.
Say again, Lon.
1, 5, 1.
I'm really having a hard time hearing.
1, 5, 1, 2.
1, 5, 1, 2? No decimal? No decimal? 1, 5, 1, 2 times 10 to the 3rd, right? Now, this is the correct answer except for 2 things. 1, don't I want to have it in good form? And 2, I want to use the correct significant figures. Didn't I have 3 right here? All the rest of these are, I mean, aren't there exactly 60 seconds in a minute? Isn't there exactly 1,000 meters or 10 to the 3rd meters in a kilometer? So those are considered exact numbers. They're not going to limit our significant figures. Are you with me? Yeah. So you're never going to go like, oh man, there's a 1 right here, so I only can have 1 significant figure. No, these are exact numbers. Most of our conversions are going to be exact numbers. So we usually go back, I'd say 95% of the time, although I could be proven wrong. Whatever the numbers are in in fact, this is what I would do. Whatever the numbers are in the original problem they give you, use that as your final answer. Yes?
But the numbers in the top, like at the top.
Yep, that I have 3 significant figures, so my answer I should have 3. So I'm gonna make this 1.51 times 10. And didn't I shift the place over 3 places to the left?
Yes.
Times 10 to the 6.
Yay.
Will you agree with me that the only extra difficulty in these problems is that you have to do 2 independent conversions, but just in one single table? But in reality, it should not be that hard. Now, the tricky thing is starting with seconds on the bottom. Sometimes you get a little bit confused, like, what do I do? Well, just put seconds opposite it if you want to cancel it out. Now, like I typically do with you guys, I give you one problem that's like, hey, here you go. Put in the T-bar and help you swing. Let's do one that's going to be a little more brutal, shall we? And it's going to force you to do a number of conversions.
I have a question.
Yes, ma'am.
Like, can I do 25.2? Like, let it go to like, because it's kilometers. I go into like meters, so it's gonna be 1,000. And then like, because it's still in seconds, so I just divide by 60.
And that's the problem, is if you've done that in your head, dividing by 60 would have given you the wrong answer. You have to multiply by 60.
Why?
Because that's how we cancel out the units.
But like,
Because there's 60 seconds in a minute,
yes.
right? And we want to do it per minute. So we have to take that and multiply by 60. And this is one of the problems if you just do it in your head and you don't do the table, you might put the seconds in the wrong spot.
No, but the question is, you are going from seconds to minutes.
Correct.
So it's like every 60 seconds you turn into minutes.
But it's on the bottom. It's per second. It's not seconds on the top. What you're doing is you're treating as if the seconds are on the top. And if that was the case, yes, you divide by seconds on the bottom. But the seconds are on the bottom, which means you have to flip it in your head. Instead of dividing by 60, you have to multiply. Which, by the way, you hear her question? She's trying to do this in her head. And I like the thought that she's doing here. The table, if we set up the table correctly, we're never going to make the mistake of accidentally putting a multiplication or division in the wrong spot. I can address this a little bit farther with you later if you want to, but you're accidentally doing this with the thinking that the seconds is on the top when you're doing the multiplication. Let's try one that's brutal. Like this is like, you probably won't see this question walking down the street, but if you can do it, and let's include exponents and everything. Let's go 4.54 times 10 to the, let's go crazy. Let's go 6th. I'm going to go miles per hour. And I want you to convert that to meters. Actually, let's go kilometers per second. And the only conversion I'm going to give you on the top that allows you to go between the English system and the metric system is 1 inch is equal to 2.54 centimeters.
It's miles per hour.
Yeah.
Miles per hour and kilometers per second. Again, I want to show you the hardest level problem so that when you see them at home, you have a hard level example to work with. So I'm going to put this in the upper left-hand corner and bottom now, right? 5.454 times 10 to the 6th. Miles on the top, hours on the bottom. We're setting that up okay? Now, watch. We can treat this. Can we treat the top by itself and go from miles to kilometers? We did one of those problems at the very beginning of the day, didn't we? Or can we start on the bottom and just go from hours to seconds? I'm going to go from the bottom first because this isn't hours per second. It's easier to work with. Now, so I'm going to ignore this on the top. And then I want to go from hours to seconds. Now, most of you here will be able to do hours to seconds in your head, right? There's 60. Well, these are the two conversions, right? 1 hour is equal to 60 minutes. And then 1 minute is equal to 60 seconds. Agree? If you want to do it in one step, you could go 1 hour is equal to 3,600 seconds. Are you okay with that?
Yeah.
But just in case you're like, don't like doing math, we're going to use these two here just so you can see the steps. Okay? So if I want to get from hours to minutes, when I use the top one and go 1 hour on the top to cancel it out and 60 minutes on the bottom? He said to the class, nodding their heads in approval.
Yes.
Hours cancel. Now I'm at minutes, right? Then I want to go from minutes to seconds. So when I go 1 minute on the top again, so I can cancel, and 60 seconds on the bottom.
Yeah.
And I'm delighted because don't I now have seconds on the bottom? Isn't that what they're trying to solve for on the top? Now, but we have not taken care of kilometers, have we?
No.
You guys remember the conversions we had to go through before? I'm gonna have to go from like miles to, let's go miles to feet, feet to inches, inches to centimeters, and then can we go directly now from centimeters to kilometers?
Yeah.
So let's do that, shall we? So you guys can write the conversion on the side. I'm just going to do them off the top of my head. Now watch. We don't care what's gone on the bottom. All we care about right now is miles on the top. So couldn't I go 1 mile on the bottom is equal to 5,280 feet? Yeah? And couldn't I then go 1 foot on the bottom is equal to 12 inches? I'm just following the conversions along the way. We did this problem in the very beginning of class, so I'm not going to explain a whole ton. I'm going to stop at the next step, though. Wouldn't I then go 1 inch is equal to 2.54 centimeters? Now, don't I have to go now from centimeters to kilometers? Now, watch. There's 2 ways to do this. Are we trying to get from centimeters to kilometers?
Yes.
So couldn't we do this? 1 centimeter equals how many kilometers? So can we do our exponent trick?
Yeah.
Just take 1 of the centimeter. And what is centi? Isn't that -2? What's kilo? What's 2 subtract 3? -2 subtract 3. Isn't that -5? So that'd be 10 to the -5. So 1 centimeter is equal to 10 to the -5 kilometers. You see how we were able to do that in one step instead of having going from centimeters to meters, meters to kilometers?
Yeah.
So can't we put this in here and go 1 centimeter on the bottom and 10 to the -5 kilometers on the top? Canceling out my centimeters and look delightfully what we have on the top. Isn't it the same unit that we're looking for, kilometers? So on the bottom here, I'm going to write my two units cheerfully, kilometers per second. But then we have a bunch of exponents, don't we? And by bunch, I mean we have 2. In the original problem, did I give you 10 to the 6th? And then don't we have, help me out here, because I'm only seeing one more, right? Is it 10 to the -5? 10 to the 6 plus 10 to the -5. Wouldn't that give me 10 to the 1? Now, here's where I want you to all do this. Okay, everyone right now pull out a calculator. If you don't have a calculator, there's paper towels on the side of the room. Pull a calculator or do it on your laptop, because what we're going to do is this. Watch. We're going to multiply everything on the top, and then we're going to divide by everything on the bottom. I do not want you to hit equal sign at all until I say. Everyone with me? We're going to do it one step at a time. Those of you who have a calculator and want to do parentheses, don't. Literally, I want to do proof of concept here. So don't we have 4.54?
Yes.
The exponent hasn't been taken care of already. So we're going to go 4.54. We're going to ignore the ones, right? Because we're multiplying by 1. That doesn't change anything. Can we go 4.54 times 5,280, don't hit equals, times 12, times 2.54, don't hit equals. Okay? Hold on. And we've taken care of them already. That's when we added these 2 together. We took care of it. Then on the bottom, don't we have 2 numbers? But here's what you're going to do. You're going to go divided by 60, don't hit equals, divided by 60 again, now hit equals. So you're going to hit divided by for however many things are down below. That is way easier than putting parentheses and dividing by. Literally, we did this. Multiply, 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 divided by, equals. What number do you get?
202.956.
Yeah? 202.956. Feels as though, 1, we have a little bit too many significant figures, and 2, not in good form. So shouldn't we slide this over 2 places to the left and go 2.03 times 10 to the 3rd kilometers per second?
I have a question.
Okay.
Why are you subtracting 5 not?
Whenever you're multiplying exponents,
Yes.
10 to the 6 is being multiplied by 10 to the 5. Whenever you're multiplying exponents, you add
That
exponents.
should be 11.
6 plus minus 5 is,
Sorry, I missed the next.
yep, it's a negative. Okay, did everyone see this? This is like the most brutal problem you're going to see. But I wanted to do proof of concept that you can actually independently deal with the top. Don't you, like, I see students sometimes put both these in the top and they're done. The problem's over. Like, there's no way to do the conversion simultaneously. As long as you put one on top and one on the bottom, you should be okay. Side veer. We're going to talk about volume, because a lot of times the unit that they put on the bottom is going to be either liters or cubic units. Now, let me remind you of a couple things. Isn't volume measured either via liquid? Like if you ever have a graduate cylinder, don't they have like liters and milliliters and whatnot in them? Or if you ever done math and you're building like a cube of some kind, don't they do like length times width times height? Don't they use cubic units? So let me start really quickly and let me remind you of the base units that we're going to be using throughout volume conversions. Okay, the base unit is this 1 liter, and this is for liquids. So this is liquids typically. 1 liter is equal to 1,000 milliliters. Now, if you're wondering how I got that, it's because 1 milliliter is equal to 10 to the negative third liters. Or I can rearrange it and say 1 liter is equal to 10 to the third milliliters. I want you to be okay with all three of these things being the same. Are you okay with all those three being the same? Because we use milliliters and liters so often, I would just say 1 liter is equal to 1,000 milliliters. That'd be my go-to conversion. But cubic units, they're a little different. There's a conversion. You can never go like directly from a liter unit to a cubic unit unless you use this conversion. Here's the conversion. 1 milliliter is equal to 1 centimeter cubed. This is the crossover between volume measurements between cubic units. Stay with me. We have like 5 minutes left. Cubic units and liquid units. So literally what would happen is this. If you were to take, if you look at the side of your finger, the side of your finger is about like, your pinky finger, is about 1 centimeter wide. So if you were to take a box and you were to build it 1 centimeter by 1 centimeter by 1 centimeter, right? Yeah. And you poured liquid into it, that one little box would occupy exactly 1 milliliter. So 1 centimeter cubed would occupy 1 milliliter. That's a conversion. So if we ever want to go from the two different units, cubic measurements to liquid or back and forth, that's the conversion we're going to use. Yes?
Not sure this one, but like if there's question for significant figure calculation, like saying adding, maybe you put 1 milliliter and then 1,
these are exact.
Yeah. Can I do subtract and add with this? Because last time when we did that, you said no.
You have to show me what you're talking about. Let me get through this and I'll answer your question, okay? Now, what's tricky is that most of us have real trouble converting cubic units to other cubic units. I'm gonna show you really quickly how we do it. And I will be honest, I didn't know how to do this well until I hit college. And even in college, when I first did, I'm like, how do they get that? I just memorized. If I wanted to go from meters cubed to centimeters cubed, do you realize it's not the same straight calculation that we would normally do? You guys know how many cubic centimeters there are in a meter cubed? Close, but not at all close.
100.
So let me show you how I do this. Do you realize that 1 meter cubed, isn't that really 1 meter times 1 meter times 1 meter?
Yeah.
So what I do is this. Whatever unit I'm going into, I figure out how many of that there are in 1 meter. Now, just in case you're wondering, isn't 1 centimeter equal to 10 to the negative 2 meters? Or 10 to the second centimeters is equal to 1 meter? Or 100 centimeters is equal to 1 meter? Aren't these all the same exact expression?
Yes.
So watch what I do, and this hopefully will help you. Wherever you see a meter, if you want to get to centimeters, just replace that with how many centimeters are in that meter. Would you agree with me that 1 meter is equal to 100 centimeters? So that'd be 100 centimeters times 100 centimeters times 100 centimeters. And if I multiply them out, 2, 4, 6 zeros, wouldn't that be 1 followed by 6 zeros, centimeters, and then the centimeters times centimeters times centimeters, and that'd be centimeters cubed? I like doing it this way. 1 meter cubed is equal to 10 to the second centimeters, right? So 10 to the second centimeters, 10 to the second centimeters, and then what I do is I just add up the exponents, and that's going to be equal to 10 to the sixth centimeters cubed. Okay?
Yeah.
Where did I lose you? Okay, so are you okay with the idea that a meter cubed really is a meter times a meter times a meter? Now, I happen to know that there's 100 centimeters in a meter, right? So if a cubic meter is a meter times a meter times a meter, and there's 100 centimeters in a meter, that's the same thing as saying 100 centimeters times 100 centimeters times 100 centimeters. And if I multiply those all out, that gives me 1,000,000 centimeters. But I also have to multiply the units. Centimeter times centimeter gives me centimeters squared. Because remember, the exponent here is really a 1. Each unit has an exponent of 1. And if I'm multiplying units that have exponents, you add them, right? So meter to the 1 times meter to the 1 times meter to the 1 is meters to the third. Centimeters to the 1 times centimeters to the 1 times centimeters to the 1 centimeters to the cube. So I originally just memorized this, and this is the conversion you need to have, is equal to 10 to the 6 centimeters cubed. But you can also feel comfortable doing other conversions yourself. By the way, this is another one I'm going to give you here, and you guys can figure this out. Do you realize if I have 1 meter cubed is equal to 10 to the 6 centimeters cubed. Isn't a centimeter cubed the same as a milliliter? Would you agree with me that it is? So can I also say that's equal to 10 to the 6 milliliters? And since sometimes we want to convert directly between meters cubed and liters, I'm going to do the math for you. 1 meter cubed is equal to 10 to the 3rd liters, or 1,000 liters. This is another conversion you can use to go. Both these right here are the same thing. Yes. But watch. This is how it's going to be. Let me show you. Because I want you to take a look at practice worksheet 2 really quickly. And I want you to look at the very bottom where they have double conversions. You guys do that for me? Can someone give me the problem at the very bottom? The first one, that's a double conversion.
It's 15 grams to kilograms over meters cubed.
Watch. So this is the problem you're going to actually kind of face, right? So let's set up our problem. When we go, whoops. When we go 15 grams on the top and centimeters cubed on the bottom?
Yes.
And couldn't we go grams to kilograms by themselves?
Yes.
And don't we know that 1 kilogram isn't it 10 to the 3rd grams? So couldn't we down here go, all right, 10 to the 3rd grams on the bottom, 1 kilogram on the top? Wouldn't the grams cancel? I'm at kilograms is what I want. Now how about centimeters cubed to meter cubed? Do we have a conversion for that now?
Yes.
Isn't 1 meter cubed equal to 10 to the 6 centimeters cubed? So we can one-step this, can't we? And again, could we go 10 to the 6 centimeters cubed on the top, 1 meter cubed on the bottom?
Question.
Yeah.
Oh.
And you got where you.
So now my centimeters cubed cancels. Don't I have meters cubed?
Yeah.
Are these the 2 units? Now I'll let you do the math on this, but that's one of the problems you have. Now, if you're having trouble with some of these, and I realize I went very quickly. So if you're like hands inside your head, like Sarah is, God bless you. I'm gonna be here tomorrow, morning, lunch, after school. My free period tomorrow is at B day, right? It's B3. You're welcome to come in here and practice on these. Now, here's what I need you to do for the next class period. Those 2 worksheets are homework. Even if you are having trouble with this, set up the problems, right? That's how you don't get it. That's how you don't get an incomplete, right? And you can still do those problems, and I'll work with you. All right. Your homeworks are worksheets, conversion practice worksheet 1 and conversion practice worksheet 2.
Question.